Right, guys, welcome to another episode on the Incredible Academics YouTube channel. So, on the previous video, we actually went through the very same problem. So, I just wanted, because that's when I was watching my own video, the one that I posted first, I realized that, okay, there was actually, another, approach that I could have used that could have, been way much, easier or, easier to understand, because remember, as a teacher, the most important thing is to ensure that I use methods that are easily understandable. Okay, so if you check, we were given that d4 is x. That is quite clear. Okay, and we know that d4 is basically an angle between a tangent. CD is given to be a tangent. And the chord BD, subtends angle A and angle E, E2 at the circumference of the cycle. So as a result of that, angle A and angle E2 are equal to X. Okay, and remember D1 was given to be Y. Do you understand? So, and D1 is basically equal to D3, because remember D1 and D3 are basically subtended by the same chord, right? Chord FE is equal to chord AB, and they both subtend D3 and D1. All right, so those two angles are equal. So D3 is Y. Okay, but also because of the fact that there's parallel lines, D2 is X. Okay, those two angles they alternate. Okay, so yeah. So now, how do we prove that? Because really the question that I want us to focus on is 2.3.3, showing that DBE is x plus 2y. That's no brainer at all. So proving that this is a cyclic quad. Remember, on the previous video we showed that H1 is equal to angle C, of which was it wasn't necessary at all. Okay, because what we actually needed to do is we needed to show that B1 is close to B4 plus 3. Do you understand? B1, which is that angle over there, it's equal to D4 plus 3. Okay, because we had already found D4 and 3 as one of the interior angles of BCDH. Okay, so going on to say, okay, let's find from scratch the interior angle C. That's a lot of work. That's what I'm saying. I always say that you need to use what's already given. But if you can't see how you can use what's already given, then come up with a different strategy, which is what I did on the previous video, because I really couldn't see how I was going to find angle B1. Do you understand? Because obviously you need to find angle B1 and compare it with one of the interior angle B2 and 3. So remember, we said that angle angle D3 is equal to Y because it's equal to angle D1. Okay, and that's equal chords subtend equal angles, and the equal chords that we're talking about, basically it's FE and AB, right? You can see that AB subtends D3, FE subtends D1, but because AB and FE are equal, then they must also subtend equal angles. Okay, right, so we've got that one, that D3 is equals to Y is equals to D1. Okay, that is fine. But remember, angle D4 is equal to X, and this is given. You can literally read it out from the information sheet. They said D3 is equal to 4, although maybe you guys can see D3 is equal to 4. d4 is equals to x. Okay, d4. So d4 is equals to x. This is given, and obviously now CDH, right? CDH, which is one of the interior angles of the quadrilateral that we're looking at, right? This is one of the interior angles. Okay, so that's just the sum of d3 and d4. So this is equals to angle d3 plus angle d4. Okay, which is just x plus y. So we've got you know, one of the interior angles. So but if you show that b1 is equal to you know, x plus y, which is this angle over here, then the exterior angle will be equal to the opposite interior. That can only apply when we've got a cyclic quad. So what we're going to do is we now try and find b1, but we can use the fact that, you know, angles in the same segment. Okay, you can see that there's this structure here, angles in the same segment. There's this structure here, right? So angle b1 is equal to angle b2 plus 1. Okay, b2 plus 1, because both the two angles are actually subtended by the arc AE, right? The arc AE. So angles in the same segment, that's our reason. So angle b1 is equals to angle d2 plus angle d1. All right, angles in the same seg. Okay, but what is d2 plus d1? So we did speak about the fact that d2 alternates with angle A. Okay, d2 alternates with A. There's our A there. It's x because of Tanquart theorem, but this alternates with d2, and d1 that was just given to be y. So d2 plus d1, that's x plus y. So now you can see that angle b1 is equal to angle d4 plus 3 is equals to x plus y. So the exterior angle is equal to the interior opposite angle. Therefore, we can conclude that BCDH is a cyclic quad. Okay, BCDH is cyclic, and that is because converse of exterior angle of cyclic quad, converse of exterior angle of cyclic quad. And someone is calling me, but we're basically done with this. I hope you enjoyed the lesson, and all the best.